Okay, here we are with assignment 6.4. This is very similar to assignment 6.3, but there's a couple keynote differences, namely that these bases don't really have much in common, or if they do, it's by pure coincidence. And two, you need to know logarithms. Okay, so let's start with the first one. Like, how can I just personally identify if I can, get a similar base and just cancel it out? Here's an example of what I mean. Let's say I have a problem that is, let's make it a little bit more complicated. 4x minus 2 is equal to 8x plus 5 or something like that. All right, so what I can do in this problem is I can turn this into 2 squared, and I can turn this 8 into 2 to the, I can turn this 8 into 2 to the third. And then since these bases are now the same, I can cancel them out. And hooray, you can get an answer pretty easily. Oops, sorry. Bad math, sorry. There. Okay, so there's that type of problem. And then there is today's type of problem. And then I'm going to talk about how these things, how you can recognize how to do it one way versus another. And today's type of problem will be something like 7x minus 2 is equal to 40 or something. I don't know. Okay, now, what you'll notice in this problem is this base number and this base number really have nothing in common. Like, 40 isn't like, 7 squared or something like that. Okay, and that's just not true. And so what you'll find is that these numbers, they may be a power of something, but they really, you are not able to get this base number to be the same in any kind of way. All right, they're going to be different. Okay, so that's one keynote difference. Another keynote difference that I see in this problem, and again, I think this might just be pure coincidence, is this. You'll notice that in this above problem, both sides of the equation had exponents. They both had stuff going on. Like the left-hand side already had an x minus 2. The right-hand side already had an x plus 5. All right, so when you have exponents on both sides, again, not all the time, but you can kind of think of it as being, oh, I can probably get these numbers to be the same thing kind of problem. Now, how to do the problems that we are going to be doing today, the one below, where the two numbers don't have anything in common, and I see that the variables are just strictly written on one side. Okay, not a big deal. What I'm going to do is I am going to write it as a log, All right, so I'm going to take this and I'm going to turn this into a log problem. I know it's been a couple assignments, but I see that the base is 7. So this is log base 7. Log base 7. And then what everything else does is it switches sides. So 40 comes dropping in, and then x minus 2 goes over there. All right, so what I do is I write it as a log. So when the bases are completely different, write it as a log. You have exponents just on one side, you can go ahead and write it as a log. And then from here, it turns into a big time calculator problem. if you don't recall how to handle this portion, like what is this, don't forget that you turn it into a division with a log on the bottom. So this left-hand side is log 40 divided by log 7. And that's absolutely a calculator kind of thing. Okay. And so it turns into some number. Okay, and so be it. Turns into some number. So this turns into particularly 1.8957. All right, not a big deal. But now I just progress like it's a normal math problem. I'm solving for x, so I add 2. So I go to this this answer. I don't know if I can, yeah, I go to this answer, and I add 2. What I did is I click this answer button at the bottom. Answer plus 2. And there it is. Okay, so again, similarities and differences. Okay, when you have exponents on both sides, like above, chances are you're going to be able to get that base number. When you have exponents on just one side, or the numbers literally just have nothing in common, write it as a log. So today's problems, I don't think all of them, but whoa, that's supposed to be an oval or ellipse. They're going to be kind of like this bottom problem, okay? We did these above problems in the last assignment. Today we're going to be focusing primarily on these bottom examples. So we have to rewrite them as a log and then just solve. All right, let's go to work. So here we go. Have exponents on one side, not a big deal. So this is going to be log base 2 of 144 is equal to x plus 3. So again, the base is the base, and then everything switches sides. So the x plus 3 goes to the right, the 144 goes to the left. I get the answer, so I turn this into a division. So this is log 144 divided by log 2. Which turns into 7.1699. And then I solve for x, which obviously means subtract 3. Round to 2 decimal places. This is going to be 4.17. 4.17. Okay, here we go. So this is log base 5. 121 is equal to 3x. Come on, calculator, don't fail me now. All right, so we get this answer. Okay, so again, what I did, that was log 121 divided by log 5. Now I just divide by 3. I need to isolate that x, so I need to divide by 3. So I take this answer, and I divide by 3. 2 decimal places, 0.99. And so here we go. Variable on one side. Go ahead, write it as a log. So this is log base 9. Everything switches sides. Okay, let's go ahead and figure that part of the problem out. Log 66 divided by log 9. Whoa, sorry. Let's try that again. Okay, so log 66 divided by log 9, that turns out to be 1.9068. Okay, solving for x, we would have to add 1 and then divide by 2. So let's go ahead and do that. So we add 1 and then divide by 2. Two decimal places, that's 4, 5. Okay. There's one thing that I kind of didn't mention, but it's an easy fix, is this. You need to have the number, the thing all by itself to begin with. So what I'm going to do is I need to get 14 to the 4x all by itself, and then everything else over there. So whether I need to add, subtract, multiply, or divide, whatever I need to do to make that happen. So in this situation, before I'm able to write this as a log, I need to get rid of this plus 7. So what I need to do is I need to minus 7 first and foremost. Then I will have my number thing isolated. So this is 4x to the 14 to the 4x is equal to 83. Now I can go ahead and progress just like I have in all these other problems. So log base 14. Sorry, really wrote it wrong. Of 83. So the base is the base, everything switches sides. So let's get that left-hand side. That's log 83 divided by log 14. All righty. To get the x all by itself now, I need to divide by 4. So take that answer, divide by 4. Okay, I just want to hypothetically do something here just real quick. I don't think it's possible, but I'm just... I think this calculator should blow up. Yeah, okay. Not a big deal. All right, so here we go. So what I'm going to do is I want to get this 4x, not negative 4x, but just straight up 4x all by itself. All right, so I see that the 5 is adding and subtracting, so I'm going to subtract by 5. And then what I'm going to do is I'm going to get rid of the negative by dividing by -1. So that leaves me with 4x is equal to 70. Okay, now I can do a lot of different things with this problem. Okay, so I want to get the 4x all by itself, not negative 4x, but the 4x itself. Logs don't like negative numbers very much. All right, so here we go. So this is going to be log base 4 of 70 is equal to x. All right, so minus 8. Write it as a log. Again, base is the base, and then everything switches sides. So the x minus 3 goes to the left, the 1002 goes to the right. All right, so the left is log 1002 divided by log 4. So that's 4.9843. Then all I have to do is add 3. I can do that now. 2 decimals would just be 90. All right, so here I get rid of that 8, so minus 8. Set it up. I have to add 3 to solve for this. Okay, here I want to get the 2x minus 5 alone, so I need to get rid of this 12. 12 is multiplying, so thus I have to divide by 12. $144 divided by 12 is 12. Now, exponent on one side, write it as a log. So log base 3. Things switch sides. And then it's just like every other problem today. So what I'm going to do is I'm going to have to add 5 and then divide, add 5 and then divide by 2. I want to get the 6 x minus 3 all by itself. 8 is multiplying, so I have to divide by 8. Base 6, everything switches sides. So log, again, I kind of assuming that you're knowing it right now, but you don't know what I'm doing, is if this is a base 6, this would be log 12 over log 6. I add 3 to isolate the x, so I add 3. All right, and then number 10. Ooh, number 10, tricky, tricky. Notice that there is exponents on both sides. So chances are these numbers are actually the same. Okay, so if you need to, what I have, 49 and 343. Let's see if they show up somewhere. 49, 343 are both versions of 7. Okay, 49 and 343 are both versions of 7. So 49 is 7 squared, 343 is 7 to the third. What do you know? So this is 7 squared, this is 7 to the third. Okay, this left-hand side has an x plus 4, this right-hand side has a 2x. But because I was able to turn them into the same number, that number drops, and now it's just old school math. I'm going to subtract 2x and then divide by 4.